Hello everyone, this is Rashmi and again I am going to discuss about some question related to determinant. Again some determinant is given in the left hand side and right hand side some values are given. We need to prove that left hand side this value is given, right hand side we need to prove that it is 0. So first of all let us start as A. Here all the elements of the determinant of the first column equal to 1. So we have already solved one question where we have made any to 1 as a 0. That means here we keep first row as it is, then second row R2 is replaced by R2 minus R1. That means 1 minus 1 0, y minus x, and it becomes y square minus xz minus x square plus yz. Then R3 is replaced by R3 minus R1. 1 minus 1 0, z minus x, and z square minus xy minus x square plus yz. Now let us see whether we are getting any common value because y square minus x square. This is in the form of a square minus b square. So z minus x. Here rearranging the terms x is y square minus x square plus yz minus xz. Simply we have rearranged the terms in this step. So z square minus x square plus yz minus xy. Okay, after that 1 0 0 x y minus x z minus x. We know that a square minus b square equal to a plus b into a minus b. We can write down y minus y minus x into y plus x. Then here z is a common value, y minus x. Then z minus x into z plus x, and y is a common value, z minus x. So you can see that here y minus x is again a common value. Therefore we will simplify the value 1 0 0 x y minus x z minus x, then x square minus yz. Here common y minus x. If you take the common y minus x, then it becomes y plus x plus z. That means x plus y plus z. And here see z minus x is a common value. So z minus x, then values are z plus x plus y, z plus x plus y. That means x plus y plus z. Now see here y minus x common value, z minus x common value. So take y minus x and z minus x in front of the determinant, and the determinant become 1 0 0. Here become this become 1 and this become 1. Then x square minus yz, and it becomes x plus y plus z. If you take the common z minus x, remaining values are x plus y plus z. Okay, after that expanding along the first column. If you expand along the first column, first element equal to 1. So 1 into x plus y plus z, then minus x plus y plus z. So 1 into this value, and see here x minus y plus z, x minus y minus z, this value equal to 0, equal to 0. So multiply any value by 0 is always 0. So in this way we can solve this question.